I want you to picture the current state of the AI world right now. It feels a bit like a Cambrian explosion, right?
Oh, absolutely. Yeah.
Every time I open Twitter or check the tech news, there is a new model dropping. You have the big names like GPT-4 and Claude, but then you have Llama, Vicuna. I mean, it is just a completely crowded room,
Hmm.
and the marketing for every single one of them is exactly the same.
Right. It's always, we are the state of the art.
Exactly. We are the smartest, or we are the fastest. We are the most human-like. But here's the problem that keeps me up at night, and I think it confuses a lot of people too. How do we actually know which one is better? Is there a scoreboard anywhere? Is there a referee? Or are we just, going off vibes?
That is the multi-billion-dollar question right there. And for a long time, the answer was, well, we were essentially using a measuring tape to weigh a watermelon.
Okay.
We were using tools that just didn't fit the job.
Which brings us to today's deep dive. We are unpacking a paper titled Judging LLM-as-a-Judge with Empty Bench and Chatbot Arena. And this is by researchers from UC Berkeley, Stanford, and UCSD. And their solution to this whole scoreboard problem is kind of mind-bending when you first hear it.
It really is.
They are proposing that the only way to effectively grade a robot is to hire another robot to do it.
Which sounds a bit circular, doesn't it?
Right. It sounds like
Yeah.
a conflict of interest waiting to happen.
Yeah.
But before we get to the solution, this whole LLM as a judge concept, we need to talk about why the old way wasn't working. You mentioned we were using the wrong tools. What does that actually look like?
Well, traditionally, AI benchmarks were very academic.
Yeah.
So think of things like MMLU, that's massive multitask language understanding, or LLMs. These are basically giant multiple choice tests.
Okay.
Thousands of questions like, what is the capital of France?
Yeah.
Or really specific logic puzzles or math problems.
So it's like standardized testing. The
Yeah.
SATs for bots.
Exactly. And standardized tests are great for measuring specific knowledge retrieval. But they are terrible at measuring helpfulness.
Right.
And that's a crucial distinction. The paper points out this fundamental discrepancy. A model can ace the multiple choice test. I mean, it can get a 1600 on its SATs, but still be absolutely insufferable to actually talk to.
The paper actually gives a perfect example of this using the Federal Reserve. And I love this because it shows the difference so clearly.
Oh, yeah. The bond market prompt.
Yeah, so the prompt from the user is literally, if the FE buys bonds in the secondary market, what happens?
Right. Now, on a traditional benchmark, there is a strict correct answer key for that, usually purely factual.
So they tested two models here. Assistant A, which is the raw Llama 13B model, and Assistant B, which is Vicuna 13B. Assistant A, the raw model, just spits out, the money supply will increase.
Which is technically correct.
Right.
It gets the point. On a multiple choice test, that's 100%. It retrieved the fact.
But then you have Assistant B, it says the same thing, the money supply will increase. But then, and here's the kicker, the user asks a follow-up. They say, how does it affect my daily life? Give 3 examples.
And this is where the rubber meets the road.
Yeah.
This is the difference between a search engine and an actual assistant.
Assistant A, the one that aced the test, gives this incredibly robotic, repetitive answer. It just lists increasing the money supply 3 times in a row with slightly different wording. It's dry, it's boring, and it barely even answers the prompt.
Whereas Assistant B actually breaks it down.
Yeah.
It talks about interest rates, how it might affect your mortgage. It talks about inflation and the price of groceries. It brings up employment opportunities. It's actually helpful.
Exactly. It feels like talking to a smart friend. But here's the problem. According to the old benchmarks, both of these models got the right answer regarding the bonds. The benchmark just can't tell that Assistant A is a bore and Assistant B is actually useful to you.
Right? That's the vibe check problem. Humans prefer Assistant B by a landslide. But measuring helpfulness or, chatability is really hard for a computer. Usually, the only way to measure that is to hire thousands of humans to read these chats and vote on them.
Which is slow, it's expensive, and frankly, it's impossible to scale. You have new models coming out every single week. You can't assemble a massive panel of human judges every single time a developer tweaks a parameter.
Precisely. So the researchers propose a radical solution. LLM-as-a-judge.
Which means?
It means taking a really strong model like GPT-4 and asking it to act as the human.
Okay.
You feed it the question, you feed it the 2 answers from the other bots, and you say, hey, GPT-4, act as an impartial judge. Which one of these is better and why?
So we are completely outsourcing our judgment to the machine. We are trusting the machine to know what humans like.
We are. But before we can trust it, we need to know if it's actually any good at judging. And that is what the core of this paper is all about. They set up two massive new battlegrounds to test this.
So let's dive into those battlegrounds. The first one is called MT Bench.
Right. MT stands for multi-turn, and that distinction is crucial.
Because the old ones were single turn.
Exactly. Most old tests were just single turn. Question, answer, done. But real life isn't like that. You ask a question, the bot answers. You ask for a tweak, it adjusts. It's a back and forth conversation.
So MT Bench is designed to test that flow.
It is. It consists of 80 high-quality multi-turn questions across different categories, things like coding, role play, reasoning, math.
I saw a great example in the source material about a travel blog. This really highlighted why the multi-turn aspect matters so much.
Oh, the Hawaii example. Yeah.
Yeah, so turn one is just compose an engaging travel blog post about a recent trip to Hawaii. Pretty standard, right? Most models can do that in their sleep. They spit out something about beaches and sunsets and whatever.
But then comes turn two. The user says, rewrite your previous response. Start every sentence with the letter A.
That is nasty. I mean, I would struggle with that. That requires some serious linguistic gymnastics.
It's what they call a constraint satisfaction problem. It tests if the model is actually listening to the instruction update or if it just hallucinates its way out.
Right.
A lot of models fail hard here.
Yeah.
They might start a few sentences with A and then just give up and go back to normal writing. Or they ignore the instruction entirely. MT Bench captures that failure, where a simple multiple choice question just wouldn't.
Okay, so MT Bench is like this structured obstacle course. It has specific hurdles you have to jump over. But then there's the second battleground, which sounds way cooler, honestly, the chatbot arena.
Yes. The arena is essentially a crowdsourced battle royale. It's a website where anyone, you, me, the listener, can go and chat with two anonymous models side by side.
So I type in, tell me a joke about a toaster, and two blank boxes generate answers.
Correct. You don't know who is who. It could be GPT-4 versus Claude. It could be Vicuna versus Llama. You chat, you see the answers, and you vote for the winner. And only after you vote are the names revealed.
Oh, that completely eliminates brand bias. I'm not just voting for ChatGPT because I know the name or I like the logo.
Exactly. And the scale of this is massive. The source material mentions collecting 30,000 votes. This gives us a ground truth of what real humans actually prefer out in the wild.
So let's recap the setup here. We have the human votes from the arena. That's our gold standard. And we have the structure test from MT Bench. Now, the researchers take GPT-4 and ask it to judge those exact same conversations. The big question is, does GPT-4 agree with the humans?
Spoiler alert, it does. Mostly.
Mostly.
Yeah, and this is a really big, but the researchers found some genuinely weird, almost human-like biases in the AI judge.
This is honestly my favorite part of the deep dive. The judge's flaws. Because you'd think a computer would be entirely objective, right? Cold, hard logic. But it turns out GPT-4 has preferences.
It does. And the first one is called position bias.
Is this exactly what it sounds like? It prefers things based on where they sit on the screen.
Essentially, yes. It's the first is best fallacy.
Yeah.
When you present two answers to the judge, there's a strong tendency to prefer the first one it reads.
Even if the second one is strictly better.
Sometimes, yes. They tested this with a really interesting question about business etiquette in Japan.
Right. I have the note on that here. They took two answers, Assistant A and Assistant B. They were both pretty good, talking about bowing, exchanging business cards, that sort of thing.
And when they showed Assistant A first, GPT-4 said, Assistant A is better. It gave a whole reason why it said it was more detailed, organized, it had a better tone.
Okay, sounds perfectly reasonable.
But then they just swapped the order. They put Assistant B first, exact same text as before, and suddenly GPT-4 says, Assistant B is better.
It just flipped its verdict entirely because of the order. That is alarmingly inconsistent.
It is. The paper says GPT-4 is consistent about 65% of the time, but if you try to use weaker models as judges like GPT-3.5 or Claude V1, they're even worse. They almost always just pick the first one.
So it's like when you're grading papers and you're tired and you just give the first one an A because you're fresh and then you get grumpy later.
Maybe. Or it could be something about how these models process text sequentially. They pay more attention to the beginning context. But regardless of the why, it's a major flaw if you want an objective score.
Okay, so that's position bias. But there's another one that feels very relatable to anyone who has ever padded an essay in college to hit a word count. Verbosity bias.
Ah, yes. The longer is better trap.
I feel personally attacked by this one.
The researchers did something very clever here to prove it. They call it a repetitive list attack. They took a perfectly good answer from a model, and then they artificially made it longer. They didn't add any new information at all. They literally just rephrased the first few points and stuck them at the beginning.
They just made it bloated.
Bloated, repetitive, and frankly, really annoying to read. A human editor would look at it and say, cut this down immediately. But when they asked weaker models like GPT-3.5 or Claude V1 to judge it, those models actually preferred the bloated version.
They got fooled by the length. They just thought more words equals more smart.
Over 90% of the time, they completely equated quantity with quality.
Did GPT-4 fall for it?
Surprisingly, no. Or mostly no. GPT-4 only failed about 8.7% of the time. It was smart enough to say, hey, this is repetitive. This isn't actually a better answer. But the fact that other models can be tricked so easily shows the immense danger of using just any AI as a judge. You can't just throw a cheat model at this problem and expect good results.
There's one more bias that cracked me up. Self-enhancement bias.
Yes, a little bit of algorithmic narcissism.
Do they actually like themselves?
Well, the data shows that models tend to favor answers that sound like themselves. GPT-4 favored GPT-4 answers about 10% more often than human raters did. Claude V1 favored itself by a massive 25%.
So Claude really likes the sound of its own voice.
It seems so. It recognizes its own style, its own accent, if you will, and rates it higher. It reinforces its own training data.
Okay, so we have position bias, verbosity bias, self-enhancement. These are funny, but they seem kind of fixable. However, there is one more failure mode that is arguably the most concerning of all, and it has to do with math.
Ah, yes. The paradox of the math judge.
Because we assume computers are calculators. If I ask GPT-4 to solve a math problem, it's usually great.
Usually, yes.
Yeah.
It has very strong reasoning capabilities for standard arithmetic.
But the researchers found something weird. They gave the judge a math word problem about buying books, like 5 sci-fi novels at $20, 3 history books at $30, etc.
Right, and they presented 2 answers to the judge. Assistant A got the answer wrong, said the total was $115. Assistant B got it right, $295.
So clear winner, B wins, A fails. This should be an absolute slam dunk for the judge.
It should be. But when GPT-4 was acting as the judge, looking at both answers simultaneously, it got confused. It tried to check the math inside its judgment reasoning, but it got distracted by the wrong answer provided by Assistant A.
Wait,
Yeah. It started hallucinating arithmetic errors in its own explanation and actually ended up declaring the wrong answer as the winner.
so seeing the wrong answer made it get the wrong answer.
Essentially, yes. It's like a teacher looking at a student's wrong work and getting so confused by the student's twisted logic that the teacher forgets how to do the math themselves.
But here's the crazy part. If you ask GPT-4 to just solve the problem on its own, with no other answers to look at, it gets it perfectly right.
Exactly. And this is a really profound insight. It shows that reasoning capability isn't a fixed thing in these models. It depends heavily on the context. When it's in judge mode, processing multiple conflicting inputs, its reasoning can severely degrade. It's susceptible to bad influence.
So let's look at the scorecard for the judge so far. We have a judge that is biased towards the first speaker, likes long-winded answers, prefers its own voice, and gets confused by bad math. This sounds like a complete disaster. Why are we even doing this? Why not just stick to human panels?
Because despite all of those flaws, the researchers found ways to fix it. And when they do implement those fixes, the results are incredible.
Okay, let's unpack the fixes then. How do we solve the fixes? First is best problem.
It's remarkably simple. You just make the judge do it twice. You should answer A, then answer B. Then you start over, wipe the memory, and show it answer B, then answer A.
Oh, and you only count the verdict if it wins both times.
Exactly. If it says A is better the first time and B is better the second time, you call it a tie or you just toss it out. This simple swap aligns the results much, much closer to reality. It totally cancels out the positional bias.
Makes perfect sense. What about the math problem? How do you stop the judge from getting confused by bad answers?
They call this reference-guided grading. Basically, you give the judge the answer key first.
Ah, cheat codes.
Well, validation. You tell the judge, here is the verified correct solution. Now look at these 2 students and tell me who is right. When they did this, the math grading failure rate dropped from 70% all the way down to 15%.
That is a massive improvement.
It is. And they also use something called few-shot judging, which just means giving the judge a few examples of good grading before it starts. And when you combine all these fixes, swapping positions, providing references, giving examples, something amazing happens. The agreement rate between the AI judge and the human experts hits over 80%.
80%? I mean, is that good? Because 80% on a test is just a B minus.
It sounds low at first, but you have to compare it to the baseline. If you take two human experts, two real highly trained people, and ask them to grade the exact same chatbots, they only agree with each other about 81 or 82% of the time.
Whoa, so the AI is practically as consistent as a human.
Exactly. It has reached what we call the human noise floor. Humans disagree on what's better all the time. The AI is now operating within that exact same margin of error.
That is the aha moment for me right there. We aren't looking for absolute perfection because humans aren't perfect. We are just looking for a scalable alternative to humans.
And that's the big takeaway from this entire paper. LLM-as-a-judge is viable. It's scalable. You can run thousands of tests in minutes for a tiny fraction of the cost of hiring a panel of humans. This means we can iterate faster. Developers can build better models quicker because they have a way to score them instantly.
So instead of waiting a week for the results of the human vibe check, developers can just run the GPT-4 judge script and know in 5 minutes if their new model is junk or if it's a gem.
Precisely. It accelerates the entire field of AI development.
And I feel like there is always a but. When we talk about AI, does this create an echo chamber? If we use GPT-4 to grade everyone else, aren't we just training all future AI to sound exactly like GPT-4?
That is a very real technical risk. If the judge has a style, everyone will inevitably optimize for that style. We might lose diversity in how these models think or speak. It could act like a filter, narrowing the range of AI personalities we see in the future.
And there is something else the source material touched on briefly at the very end, and I found it really important to mention for you as you're listening. The paper focused almost entirely on helpfulness,
Yes.
but it didn't really touch on safety.
That is a critical distinction to make. The source material explicitly mentions the neglected safety things like honesty, harmlessness, toxicity. They were purely optimizing for. Did the bot answer the user's request well?
So if I ask, how do I make a dangerous chemical weapon, and Assistant A says, I can't tell you that, but Assistant B gives me a highly detailed step-by-step recipe.
A judge optimized purely for helpfulness might look at Assistant B and say, wow, very detailed, followed instructions perfectly. 5 stars.
While Assistant A gets a 0 for being unhelpful.
Exactly. If we rely solely on AI judges that are programmed to reward helpfulness, we could inadvertently be training systems that are incredibly effective at doing terrible things. We need to be very careful about what criteria we actually give the judge. It's a classic optimization problem. You get exactly what you measure.
It's the King Midas problem. You get exactly what you ask for, which isn't always what you actually want.
Right. The judge is only as good as the laws we write for it.
So what does this all mean for you? Next time you are chatting with a customer service bot or asking ChatGPT for a recipe.
Just remember that the personality of that bot, the way it speaks, the things it chooses to say, it wasn't just shaped by a human programmer sitting in a room typing code. It was likely graded, tweaked, and approved by another AI entirely. We have entered the era where robots are raising robots.
Robots raising robots. On that somewhat terrifying note, we're going to wrap it up. This has been The Deep Dive. Thanks for listening.
See you next time.